Let's go. Benchmark. I want to plot some graphs for the benchmark. I want to tell the story that what is the difference. We talked about it. We added remarks on different benchmarks, the differences between revenue, optimal revenue when there is no constraint, revenue when there is only truthfulness constraint and no obedience, and when it is just every constraint is involved. And the same with welfare. And we talked about that for revenue, it's the case that all three are different. So let's do that. And where is it? This is the benchmark, all the stuff. This is the benchmark we are talking about. Truthfulness without obedience. Name of the section. Okay, the writing of the section is quite good. Remark, the first plus mechanism and the complete information hash equilibrium are truthful. Well, not are truthful, but by equation and the first part of the proposition holds. The payment of the mechanism can be second part of the can be, I want to say they're not truthful, but can be implemented in a truthful manner. Can be implemented in a truthful manner. I don't know. Truthfully manner. So the first plus mechanism and complete information Nash equilibrium can be implemented in a truthfully. By this and this, one can see that this is greater than 0 and the first part of the proposition holds. The payment mechanism can be computed using second part of and the participation. Alright, let's go next one. That's good enough. The relaxed version of the optimal revenue problem, which does not require incentive compatibility constraint, is individual, and the only constraint is individual rationality, has the same information structure as the first plus mechanism. In this mechanism, the types are known and the buyers will follow the recommended action by assumption. We have PI UIO for MI that minimizes UIO. As one can see for the revenue, this relaxed version, no incentive compatibility, is different from the less relaxed version of truthful mechanisms where buyers follow recommended action. Less relaxed version of truthful mechanism. Less relaxed version of truthful mechanism where buyers follow recommended action. Okay, in my head it's just Monzer is teaching reinforcement learning. I wanna find out if I can join the class and audit. That will be good. That's it. Just write it down somewhere. Alright, as one can see for the revenue, this relaxed version, no incentive compatible, is different from the less relaxed version of truthful mechanism where buyers follow recommended action. However, for the welfare, these two benchmarks ended up having the same information structure. So, writing is pretty good, I say. Let's just add the plots. Let's just add the plots. Anaconda. Drive, desktop. Alright, and Python, no, not Python. Python practices exact. Research, Gaussian. So, benchmark versus revenue optimal, benchmark, complete information Nash. What is this one? Okay, that's bullshit. We don't want this. Delete. Let's clean the space a bit. Delete. Collaborative optimal revenue, competitive optimal revenue not done. This is the one that has the most thing, right? RWCB. And it has revenue, it has welfare, it has everything. Exactly. So this one is good. These are bullshit. From now we don't need them. Benchmark we want, benchmark versus the other one we want. Let's go on benchmark, let's see what's going on here. NumPy has NP typing list, N is this, and G return X coordinate of the optimality point. Return Y coordinate, and they return the whole thing. And the 1 or 0, X will be 1. If X is greater than or equal to 1, X is 1. And what is the third parameter? Third parameter says if it is binding or not, right? And if X is 1, Y, X is less than 1, we will have it at 1, Y will be the same, and the constraint is binding. Slash xi is a slack of the equation in proof of benchmark. Perfect. For R in this range, we want to do this. And notice the benchmark, the first best are defined in this range. Optimal revenue is defined in a wider range. So once we want to plot them next to each other, we will use the narrower interval of first best and optimal first best and optimal mechanism which is truthful without obedience. TWO. Perfect, that sounds really good actually. So we have the benchmark. Let's add the for the welfare we don't need such a benchmark because it is already the first bus is already obedient. So that's it. That's the only one that matters. This is revenue. Perfect. Well, actually, that's this one. How did okay cell type? But okay. Truthfulness without obedience. And I have to add first best. That's what I need. The payment from the first best. Alright, that is not very difficult too. I will add it because I have the revenue already. Let's before making it too complicated. First best. Maybe actually adding first best before. First best, but what is it? Payment is from only individual ration. Only. So what is the first best? Where is it? It's here. First best is this, and we have the formula for AI. So who put it here? First best AI is theta I something theta j plus uh, something omega, right? Uh, Now, what is the payment for it? Payment is payment is not this. This is the truthful payment. Participation. We should go to participation. Here. Let random variable UIO is then their interim reservation utility is given by this. In the first best, we can force people to follow the recommended action plus S mu omega plus T mu theta I, right? And we choose MI that minimizes 1/2 R1. That is it. And okay, I'm not sharing with you. This proposition is for truthful and truthful telling. We don't need this. These are all truthful stuff. Exactly. So we just want UI minus UIO be greater than PI. Where is this constraint? It's not mentioned here, but it's kind of funny. Yeah, maybe just mention that definition. Even when a player chooses not to participate in the mechanism, their utility is still affected by the action taken by remaining players. Although we wish to design a mechanism in which all players participate at equilibrium, specification of path mechanism, that is the mechanism used when a player chooses not to participate. Utility of non-participation. In this section, we investigate reservation utility on the off-path mechanism, a mechanism, each of this significant signaling function, a payment function. Perfect. But we were only one is out. Thus, even though the description of a mechanism is a priori exponential in the number of players, the following lemma shows that as far as participation is considered, the choice of an off-path mechanism can be parameterized by a single number. The mean aggregate action lemma for I, the random variable distributed according to this mean aggregate action. Interim reservation utility. I think I need to add it here. S is the participating. Yeah, I need to. Where is this? Given the outside options, the individual requires is it M? Yeah. Fuck it, I wrote it, they can delete it later. What is it? Time. Is it tall or is it sigma? Tau. So this should be greater equal, the same shit for tau s. You know what? I don't want to give them idea to make this paper more complicated. Fuck that, dude. Yeah, are you looking for a problem? People who read these papers are not dumb fucks. They're smart people. So they better figure it out on themselves. I cannot explain everything obvious. Come here. I think actually your default should be the fact that people understand what you wrote. And if they have problem, they can ask me. Common sense. I cannot explain everything. It's just waste of time for both of us. Reader gets bored. Alright. So that's it. AI is this, UI is this, PI. UI minus PI greater than UIO of theta I. And Yeah, before receiving the recommended action, you want your expectation be greater than UIO. So where is it? So fucking big. Who writes the big papers? This is stupid. So PI maximize it will be UI minus UIO of theta I. But what is UI? Expected of UI. Theta I. Do we have that number for first best? We don't. Pi of theta I. Pi of theta I should be less than ui tilde of theta I minus uio of theta I. That's what we want. We need to choose mi and I need to compute uio tilde of theta I. Yeah. Yeah. Truthful and individually rational manner. Okay, that's the way to say it. But the thing is that I don't know how to choose mi for each theta I. Mi is a constant, it cannot be a function of theta I. So we are first best, we have the action recommendation. By the way, we know expected of UI in general. But I don't, okay, it is mu AI squared plus sigma I squared over 2. I don't know if it is in general or it's for an obedient mechanism. Alright, let's go. Okay, well, for obedient mechanism, so we cannot use this formula. Perfect. So we have to compute it ourselves. Alright. So that's the AI. We have is AI is S omega that's AI. S omega over 1 minus n minus 1 times 2r plus 1 minus n minus 2 times 2r times t theta I over 1 plus 2r times 1 minus n minus 1 2r plus 2RT sigma j equal I theta j over 1 plus 2r 1 minus n minus 1 2r. And I wanna also say that UI equals minus 1/2 AI squared plus R AI mod J not equal to I AJ plus s omega plus t theta I. Yeah, actually, the AI we just wrote down is the argmax of this function. Now we want to actually compute it easier, and let's have the inequality, then we decide on mi. Alright, okay. If you do differentiate ui with respect to ai, we will have minus ai plus r sigma j not equal I aj plus s omega plus t theta I equals 0. Therefore ai is r j not equal I aj plus s omega plus t theta I, and then ui will be minus 1/2 this term squared plus r sigma j, actually this is the term times ai squared. So it is 1/2 the term squared. So which is 1/2 ai squared. Makes sense, okay. ui is 1/2 ai squared, and we have it. So therefore ui tilde of theta I will be 1/2 expected of ai squared given theta I. I want to mention, let's go ChatGPT. Why are joint Lie Gaussian random variables x squared given y. Give me denote what is the formula for rho based on, how should I compute? How should I compute x rho based on expected of xy? So perfect. So ui tilde will be 1/2 expected of ai squared given theta I, which will be 1/2 variance of x given a given theta I, which for Gaussians do not depend on theta I, and it is the beauty. Variance of ai given theta I, 1/2 variance of ai given theta I, plus expected of ai given theta I squared, right? And variance of x given y, variance of ai given theta I is sigma ai squared, we actually have it, minus sigma ai theta I squared over sigma theta I squared. That's what we have, right? We have it somewhere, I don't know where. Should be in participation, by the way. Oh, it's here. Can I say expected of variance of x given y equals variance of x minus covariance of xy squared over variance of y. Yes, sir. Alright, perfect. So that's it, sigma I theta I squared over sigma theta I squared. And we need the expected of AI given theta I. Expected of x given y is mu x plus sigma xy over sigma y, not sigma y squared, y minus mu y. That's it, right? Actually, we have expected of AI given theta I. That's it. Oh, so it is variance sigma y squared. Perfect. Expected of A on given theta I will be mu AI plus sigma AI theta I over sigma theta I squared theta I minus mu theta I. Alright, perfect. And where's YO? One half T. So we require that to work. Sigma I take. It was one half T, right? T squared. That's sigma AI theta I. One half, oh, we have one half here too. Sigma theta I squared which will be sigma AI theta I over T sigma theta I squared. So 1, I can say T squared and say T sigma AI theta I 1. Is that the case? So we require sigma AI theta I over T sigma theta I squared be greater than 1. That's it. They are truthful, but are they also IC? Okay, so this x greater than 1 is just IR. Alright, Oh, we don't have double. Alright, is that the case for the first best? Sigma I theta I greater than 1. Yeah, we did this computation before. So now, let me compute sigma I theta I. Variance of AI given theta I is sigma AI squared. Sigma AI squared, what will be sigma AI squared? That's not very difficult, we computed this before. It is just 2R. Everything is welfare or revenue, but everything is 2R. No, it is variance of A. I guess it is this, just 2R, change it with 2R. Sigma AI squared will be S squared sigma omega squared S squared sigma omega squared over 1 minus n minus 1 2R S squared sigma omega squared plus 1 minus n minus 2R squared T squared sigma theta I squared. We won't have any cross factor. Theta I, theta j, theta I, omega. They are all independent. 1 n minus 2, 2R. These 1 plus 2R squared 1 minus n minus 1 2R squared plus 2RT squared and then n minus 1 sigma theta I squared over 1 plus 2R squared 1 minus n minus 1 2R squared, which will add up to so they share the denominator. Sigma theta I is the common factor, T is the common factor, will be plus 2 minus 1. Oh, not n minus 1. Why 2R squared? Yeah. That's it. I don't actually need to compute it because we have it. This will end up being, actually that's enough. That's good to go. What did I write here in my code? N minus 1 r squared plus 1 minus n minus 2r squared t squared variance of theta I squared over 1 plus 2r squared times 1 minus n minus 1 2r. Exactly, that's the same term, just everywhere but that we have an r, we should change it to 2r. And what about sigma ai theta I? And what about mu ai? Okay, we have ai, so mu ai is not very difficult. Sigma ai theta I is, I can say it easily, sigma ai theta I is 1 minus n minus 2 times 2r sigma theta I squared t sigma theta I squared over 1 plus 2r 1 minus n minus 1 2r alright, that's it. Then this motherfucker should be greater than 1 minus n minus 2 2r 1 plus 2r. Well, it is true for r minus 1. Well, we know that it is true for r when r is between, so when 2r between minus 1 and 1 over n minus 1 is true. So it is true always. At least for that range. Alright. Then we have ui tilde based on theta I, perfect. Then we say pi of theta, now it's about the time for m. Pi of theta I is less than equal ui tilde of theta I, which is completely defined, minus ui o of theta I, right? And ui o of theta I depends on m for each theta I. Now what m should we choose? Let's choose one that maximizes expected of payment. Alright, that makes sense. Because we are doing it for the revenue, let's do it one that maximizes for expected rate payment. So I also mentioned it here, by the way. Because we are going to maximize expected revenue. Makes sense. So okay. What is it? Where is it? Ui O of theta I. Ui O of theta I is 1/2 RMI plus S mu omega plus T theta I squared. Expected of Ui O of theta I will be G's. It will be 1/2 RMI plus S mu omega plus T mu theta I squared plus 1/2 variance of T theta I, which is T squared sigma theta I squared. Expectation of x squared is variance of x plus mu x squared, right? So that's it. Now the mi that minimizes this term, mi, we want the quadratic term to be 0, we will say, I may need to share it with you guys. Okay, my battery is running low too. Anyways, it's not a big change. Mi will be, maybe I can take it from here, add it to here. Mi will be, that should be 0 minus S mu omega plus T mu theta I over R. That's the mi, and then pi, again we want to go pi, then ui tilde theta I will be, we're saying it right, ui of theta I will be S mu omega 1/2 T theta I minus 2 theta I. And this will lead to ui squared, right? And we'll have 1/2 T squared theta I minus mu theta I squared. Perfect, we can add it to the remark too. And then we can say, actually I think we have it. Where is it? downside option. Oh, I couldn't see that. Perfect. And that's it. So then we can say pi of theta I is ui of theta I, ui tilde of theta I, which we computed. Where's the formula? Exactly. It is this. So this is ui tilde of theta I minus ui o of theta I, which is 1/2 t squared theta I minus mu theta I, which will be 1/2 variance of ai given theta I. What is it? I computed. It's this. Copy. Paste. Plus expected of ai given theta I just did it. Minus 1/2 t squared theta I minus mu theta I, and we will have, okay, we had sigma ai computed, right? This, and we have sigma ai theta I. I will add them to the code once I want to add them, so that's all good. The thing is that we just plot for r. If I want to go expected value of pi, if I want to go expected value of pi, so pi of theta I is, we are setting it as ui tilde of theta I minus ui of theta I, ui o of theta I, but we know that ui tilde of theta I is 1/2 expected of ai given theta I, ai squared given theta I, minus 1/2 t squared theta I minus mu theta I. Then we will have expected of pi will be 1/2 sigma ai squared minus, not sigma AI, sorry, expected of AI squared minus 1/2 t squared sigma theta I squared. So it will be 1/2 sigma AI squared plus mu AI squared minus t squared sigma theta I squared. Alright, let's add this. First, at the end of the see for the revenue, this relaxed version runs into from the less relaxed. We have for the relaxed version, same information. In this mechanism, the types are known and the buyers will follow the recommended assumption. We have this. Alright, let's say this. Let's keep that. Minimizes this. For MI, the choice of MI what's wrong? Equals over R leads to UIO. Two what's wrong with it? now it's good. What is wrong? Well, I am using dollar sign. Jeez. So now it's just explaining to the mathematics. Yeah. Alright, the relaxed version leads to breaking. What is wrong with this part? Well, it's closed here. What are you talking? If I cut this, it will be okay. What is wrong? Just that. Wait, how did it change? What was? I cannot see. Reset. I like set better. Maybe frac is not a good option. Okay, this is good. And then okay, that's it. We have everything now. All right, I have to go attend the seminar presentation. So we do the code later.